we work in an exciting area that connects classical mechanics with quantum information science. In particular, our research and the research at the New Frontiers of Sound, the NewFoS Center, focuses on creating new ways to process information using mechanical systems, like sound waves traveling through specially designed materials. These materials, called metamaterials, are engineered to support special types of acoustic waves that act like the binary digits or bits in traditional computers. However, unlike traditional bits, our bits, what we call phase bits or phi bits, can exist in multiple states at once, similar to quantum bits or qubits. This could potentially lead to more efficient parallel computing systems. To give you an example of a recent project and its findings, recently an experiment involved creating phi bits using acoustic waves in a material made up of coupled acoustic waveguides. These waveguides allow sound to travel through them in efficient ways, in special ways, I should say, and we found that we could manipulate the acoustic waves to mimic quantum-like behavior without the fragility and the complexity of traditional quantum systems. This is a major step toward achieving more efficient, scalable, and stable computing systems. Our research could significantly impact the way we think about computing. By using mechanical systems like sound waves, we can potentially build powerful computing platforms that are more stable, accessible, and easier to control. Our research also bridges the gap between classical computing and quantum computing, which could lead to breakthroughs in solving complex problems in science, technology, and industries like medicine, AI, and material science. An upcoming project in my lab is focused on something called miniaturized acoustic waveguides. We are developing ways to scale our systems so they can be used in real-world applications. This involves refining the techniques we use to control the acoustic waves and finding better materials for the waveguides. The goal is to make these systems small enough and efficient enough to be used in real-world applications. Our approach uses something called finite element analysis, FEA, a computer simulation technique, to predict how these miniaturized waveguides behave under different conditions. This lets us experiment with various materials and shapes to find the most effective way to control sound waves at a very small scale. While the basic ideas behind our research could be done at any university, this work is particularly well suited at our lab and at the NewFoS Center because of the specialized equipment we have, like the ultrasonic spectroscopy and the scanning laser Doppler vibrometry, to fully characterize the characteristics of nonlinear acoustic fields. We have a strong collaborative environment with experts in mechanical engineering, quantum mechanics, and material science. This combination of expertise and resources makes our lab and the NewFoS Center the perfect place to push the boundaries of what we can achieve in this field. The idea of combining classical engineering with the amazing possibilities of quantum mechanics is a fascinating topic. When I discovered the potential of acoustic waves in metamaterials, it felt like the perfect opportunity to explore how classical mechanics could mimic quantum behavior. Our lab and the NewFoS Center is a great place because it provides the ideal environment to dive deep into this intersection with its focus on both innovation and collaboration. The potential for real-world applications such as quantum-inspired computation made this the perfect place for me to pursue my research. If you are passionate about pushing the boundaries of what we can do with engineering and computation, then our lab and the NewFoS Center is a great place to explore those interests. We welcome students to get involved in exciting projects where you can learn both the theoretical concepts and hands-on skills which are needed for cutting-edge research. Whether you are interested in acoustics, information science, or material science, there are plenty of opportunities to learn and contribute. Plus, you will be part of a team that's working on groundbreaking projects with the potential to shape the future of technology.